So now we've seen how to graphically represent our budget through the budget constraint, and how we're going to graphically represent our preferences, or how much people prefer of different goods, using the indifference curves. We can bring them both together to talk about utility maximization. Utility maximization. So let's draw out these two concepts that we talked about. So we have Cartesian plane here. Let's keep using that example. We have mangoes on our y-axis, fish on our x-axis. So if you remember, we have, if we assume that first scenario is true, where the price of mangoes, so let's say our budget equals $1,200, the price of fish equals $4, and the price of mangoes equals $1. This intercept would be 1,200, this would be 300, so we'd have this as our budget constraint. And we have different preferences, and so, in more advanced classes, maybe we'd have functions to represent these indifference curves. But here we're just going to draw them out. And so remember, we want to be on the highest indifference curve possible. So let's say we had an indifference curve that looked like this. Let's call that I1 or something like that. Well, we could definitely, we could purchase, could afford, if we spend our whole budget, we could purchase, either of those two combinations. But remember, we prefer to be on the highest indifference curve possible. And think about, there's an infinite amount of these indifference curves kind of fanning out away from the origin in a similar shape than this. We still want them to be bow-shaped. Shouldn't kind of kick in like that. Should continue on like that. And so what we're going to do is find the indifference curve that is just tangent or just touches the budget constraint. And that's going to be, and where that indifference curve, the highest indifference curve possible that just touches our budget constraint, that's just tangent to it, that's going to be, the point at which that occurs is going to be our optimal consumption bundle. So for instance, what this is saying is point A, if we label this point A is the optimal consumption bundle. So what that's saying is that this point A here, this is our quantity of fish. This is our quantity of mangoes. Oops. A and A, let's say. It's supposed to be an M up there. No, the writing's pretty small. So that quantity of fish combined with that quantity of mangoes is the combination of goods that maximizes our total utility. So combination of goods of QF and QM that maximizes total utility given our budget constraint. And there's more indifference curves out here. There'd be another one, there'd be like an I3 out here, but we can't afford any combination of those goods or any of those bundles along I3. So we want to just draw out our budget constraint, and we're going to figure out what indifference curve, or we're going to draw an indifference curve that is just tangent to our budget constraint. And that's going to be the highest indifference curve we can get, where we can just afford one of the bundles of goods. So let's think about what this graphical, what's true at this point A. Well, what's true at this point A is that the slope of the budget line is equal to the slope of the indifference curve, because they're tangent. So at point A, the slope of the budget line equals the slope of the indifference curve, of the indifference curve. And if we think about what those two things are, well, the slope of the budget constraint is the price of fish over the price of mangoes. Well, it's the negative of that, actually, since it's a negatively sloped line. And then if we think about what the marginal rate of substitution or the slope of these indifference curves are, it's going to be the marginal utility of F over the marginal utility of M, because it's this trade-off between marginal utilities. It's how much, we talked about the slope is capturing and the marginal rate of substitution is capturing how much of one good you have to give up to be just as happy as you were before. So how much good we have to give up to get another one or something like that. And so if we think this is kind of the criteria, so we can get maybe rid of these negative signs. If we think about what our maximization criteria was before, so this is what it is now, that the price ratio equals the ratio of marginal utilities. So this is what our maximization criteria now looks like on the graph. But this is, we can rewrite that equation like this. And remember, this is exactly the criteria we were looking at when we were doing this maximization. We had the actual numbers. Remember, this is the bang for our buck of fish, and this is that bang for our buck of mangoes. So the criteria is the same. We're just representing it in a different way. So that's how maximization works here. So these would be particular numbers that would maximize our total utility. Now let's go back and think of those two different things that could happen to our budget constraints. So we're going to assume our preferences don't really change, but maybe our income would change, and that would change what point A, like the optimal consumption bundle, that would change it if our income changed, or if the price changed. So let's take a look.